All right, so in this video, we're going to talk about error intervals. So what they basically are just, let me say, limits. Okay, limits. So usually you have your lower limit. So how it looks like is you have your lower limit less than or equal to x, and which is less than your higher limit. Okay, this is how it is. So this one is usually less than or equal to, and this one is just less than. Okay, there's no equal to here. Um, So X means it could be any values within this range. Okay. Now let's actually answer the questions. Now find the error interval of a rope that measures 53 centimeters to the nearest centimeter. So usually, so let me erase this. All right. So usually the first thing you do is identify so I'll put the steps here. Identify your degree of accuracy, and they usually give it to you. So in this case, the nearest centimeter. So our degree of accuracy is 1. So whenever they whenever, so whenever the question says, oh, like the nearest unit, for example, the nearest centimeter, the nearest kilogram, the nearest minute, something like that. Okay, these are the units, these are the nearest units, and your degree of accuracy is just 1. Or when you say the nearest whole number, the degree of accuracy is also 1. Okay, so when they give you something like this, you just know, okay, your degree of accuracy is 1. And the next thing you do is you divide your degree of accuracy by 2. So let's say B, divide degree of accuracy by 2. So if we do that, we have 1 divided by 2, which is 0.5. All right. The next step is, let me just write C, add and subtract to get your limits. So again, okay, from 0.5, all right. So the measurement they gave us was 53. So what we do is just add 0.5 to get our upper limit. So 53.0.5 is 53.5. And then we subtract 0.5 to get our lower limit, which would be 52.5. All right. So then we can write, right? So 52.5, you can put the unit centimeters, is less than or equal to x, while x is less than 53.5 centimeter. And this is your error interval for this question. Okay, it means that the value falls within this range. The value can't be 53.5. Why is that? Because if you approximate 53.5, okay, to the nearest whole number, you will get 54. Okay, because this is 5. Once the next value is 5 and above, you round up. Okay, so that's why 53.5 is not included. So this is just, so our error interval is just this. Okay, so if I pick, say, a number like within this range, say 50, let me say 53.2 centimeters, for example. I round it or I approximate it, I'll still get 53. If I pick somewhere, let's say 52.7, if I approximate this to the nearest whole number or the nearest centimeter, I will still get 53. So that's just the idea of error intervals. So it means this would be our answer. So let me write it. Let me type it out. So the answer here will be 52.5 centimeter is less than or equal to, let me get the symbol. Okay, so it's less than or equal to x, or x is then less than 53.5 centimeters. All right, so let's go to the next question. A cup is measured as 150 grams, rounded to the nearest 10. Find the error interval. So again, it's still the same steps. Okay, we need to identify our degree of accuracy. So we'll just determine your degree of accuracy. So what is the degree of accuracy here? They've given us the nearest 10. Okay, so our degree of accuracy is going to be 10. So usually they would give you in the question. Okay, they would. But if they don't, like, for example, okay, just for example, they say a cup is measured as 150 grams. So let me, okay, and maybe they ignore this rather to, you know, okay. They just say a cup is measured as 150 grams. Once they don't give you any degree of accuracy, okay, you could assume it to be, the nearest gram or the nearest whole number. Okay, that's if they don't give, but most of the times they will give. But if they don't, it's most likely going to be to the nearest whole number, which means your degree of accuracy is going to be one. That's only if they don't give. So we go back to this. Let me, mm, okay, got it to the nearest 10. So our degree of accuracy is 10. So again, next step is to divide the degree of accuracy, divide by 2. And what is 10 divided by 2? 10 divided by 2 is 5. Same steps, we now add and subtract to get our lower and upper limits, or upper and lower limits to be precise. So add and subtract. Okay, so the value we had was 150 grams. Add 5 to it to get 155. Subtract 5 from it, we get 145. Then we can now write our error interval as, okay, remember, we're going to have 145 grams is less than or equal to x, and x is now less than 155 grams. Now, does it have to be x? Do we have to use x? It depends. You can use y or a. It depends on what your I think most math question or most math um, re resources will just use x, but I think you can use, I think x is just the most common one to use, but then you know, you can decide to use any letter that you're comfortable with. So this would be our error interval. All right. So 145 grams is less than or equal to x, and x is less than 155 grams. Okay, let's go to the third question. And now the mass of an element was given as 0.0833 kilograms when rounded to three significant figures. So obviously we're going to have to find those. So I think find the error interval. So we're looking for the error interval. Now again, now in this case, they give us significant figures. So how do we do it? So what do we do here? Okay, so determine the degree of accuracy. So since it's three significant figures, we go to the third significant figure. What is the third significant figure here? We count from the first significant figure, which is 8. So 1, 2, 3. We determine the accuracy of the third significant figure. So this is so let me just write it out so we can 0.0, sorry, 0.0833. And the third significant figure is this one here. Let me use a different color, which is this one here. Okay, so this is our first significant figure, second significant figure, third significant figure. So the degree of accuracy will simply be 0.0001. Okay, we're going to have to match it with the third significant figure. That will be our degree of accuracy. So when you want to get the degree of accuracy for maybe significant figures, you go to the, since we're looking at three significant figure, we go to the third significant figure and determine our degree of accuracy. So it means our degree of accuracy here is, let me go back to black pen, 0.0001. So I do this so that, we won't make any mistakes. Let's go to the next one. We still divide by 2. So divide by 2. So what is 0.00001? 0.0001 divided by 2. That will simply be 0.000, add an extra 0, and then 5. This will be 0.00005. Sorry about the many zeros, but we just need to know this. All right, and then we do the same thing, add and subtract. So C, add and subtract to get our upper and lower limits. So obviously we have 0.0833 plus 0.00005. And I said we can have minus 0.00005. What this gives us, okay, let me do it with you. So let me just do it manually. So if I write 0.0833 minus 0.00005, I can now add an extra 0 here, because there's nothing after the 3, I can just assume it's 0. Okay, what do I do? Obviously, 0 can subtract 5, so I bring 1 from the 3. This becomes 10. 10 minus 5 is 5. We are left with 2. So this is 2 minus 0 is 2, 3, 8, 0. So it means our lower limit will be 0.08325 kilograms. And then on the other side, since we're just adding 5, okay, let me also do it, 0.0833 plus 0.00005. Can add a 0 here so that the number of decimal places are the same. So 0 plus 5, everything just 3, 3, 8, 0. Okay, so it means our upper limit is 0.08335 kilograms, and then we can just put less than or equal to x. X is less than this. Okay, I know it's a lot of the decimals, but just in case you see something like this, you won't be surprised. Okay, so again, when they give you you have to find your degree. The most important thing is just find your degree of accuracy. So from there, you'll be able to just divide by 2 and then add and subtract to get your limits. Okay, so this is for significant figures. All right, let's go to this one when we have decimal places. Now, upper rounds to a number to two or decimal places. Okay, she gets 8.36. What is the error interval of the number? So again, we have 8.36. So the first thing we have to do is identify or determine the degree of accuracy. Two decimal places. So this is your first decimal place and your second decimal place. So your degree of accuracy is going to be on your second decimal place. So it's going to be 0.01. The degree of accuracy is just going to be 0. Like you follow the degree of accuracy of this number here. So 0.01. Okay, so let me write that down. So again, we determine degree of accuracy, which is 0.01. We just did that. Range 0.01. Okay, number 2, we divide, next step, we divide by 2. Divide by 2, which is going to be 0.01 divided by 2, that's going to be 0.005, and then same thing, add and subtract to get our limits. Okay, so we have 8 points. So let me use a black pen. 8.36 plus 0.005 minus 0.005. So in the end, we're going to get, um, let's see. So 8.36 minus 0.0, that's going to be 8.3555. Then on this side, we're going to have 8.365. Right, so it means our error interval is going to look something like this. Since there were no units, so there's no like they didn't give us any units, so we just leave it as it is. So 8.355 is less than or equal to x. Like I said, you can use let's use a different letter this time. Let's say a is less than 8.365. Okay, so it's always less than the higher limit, but then the lower limit is less than or equal to. Like that, we're done with this. Now we have the issue of truncated in values. I wanted to make this a separate video, but I think I'll just do like one question on these ones, and then maybe I'll make it into a separate video. So if, truncated. So when you say truncated numbers, so let's know the difference between truncated and approximated numbers. So if I say approximate 4,379 to two significant figures, so two significant figures I count. Okay, let me say one, two. So this is my second significant figure. Okay, so this is where I want to stop. Now I check the number after the three. Is it five and above? Yes, that's seven. So it means we're going to round up. Okay, so it's going to be plus one. In the end, we have four, four, and then the rest is zero, zero. So these are two significant figures. Okay, even, how do I say this? We don't just ignore the other numbers. Like our answer won't be just 44. Okay, because this is actually a large number. We can't just ignore, like cut them away. That will work. Okay. Now, so our answer will be 4,400. Okay, to two significant figures. All right. Now, when we truncate, okay, truncate simply means to delete, okay, or to cut away. So we don't need to even like we don't need to know what comes after. So 4,379 truncate to two significant figures. Okay, so one, two. Sorry, let me use one, two. So three is a second significant figure. When we truncate, we simply delete everything that's here. That's after the three. Okay, it just becomes zero. So we have 4,300. So that's the difference. When you truncate, you are simply deleting, like you're not approximating, you're not going to round up or round down. Like you don't care about that. You just want to, it's like ignore everything else that's here. But when you approximate, it's more, okay, what is after the second significant figure? It's 7, so you round up. Okay. So because of this, truncating will have a slightly different error interval. Okay. So um all right, so you can do this on your own. Perhaps like I said, I'll make a separate video on this. Yeah, you can just try. I'll make now a number has been truncated to 34.08. 34.08. Find the error interval. Okay, so obviously what we have here is 34.08. It means when we truncate, it means that anything after the 8 was already removed. Okay, was gone. So what could be the error interval here? Okay, now for this one, all we have to do now, well, what is the degree of accuracy here? Okay, the degree of accuracy here is 0.01. All right, 0.01. So we don't need to divide. We don't need to divide, we just add. Okay, so we have 34.08 plus 0.01, which is 34.09. So it means that whatever value we have, it falls between 34.08 is less than or equal to x, which is less than 34.0. Like this becomes your lower limit. Okay, your initial value now becomes your lower limit. Okay, because you cannot, when you truncate, you can't actually go lower than that. All right. When you truncate, you can't go lower than that. So it means that um, this will be your error interval. Okay. 34.08 is less than or equal to x. And it makes sense. Let's pick a number that's going to be around this range. Let's say we have 34.08. Let's add something else. Something else will be 30.08597. Okay. Once we truncate to two decimal place, it just means we're going to delete anything that's after the 8 and we get back to 34.08. Okay. If we say now, once we have 34.09, you can no longer, like, it's no longer going to give you 34.08. Okay. So this will be your answer. Right. So like I said, I'll try and make a separate video on this for a truncated number, but I think you get the idea. So that number that you've truncated, okay, like the answer you get when you truncate automatically is your lower limit. Okay, all you have to do is find your degree of accuracy since it's two decimal places. Um, just add it. Okay, find your higher limit, and then your values will be between them. That's you don't have to divide your degree of accuracy when you're finding the error interval of truncated values. So that's it. I really hope I helped. Thank you.